to now derive the Phillips curve from the weight setting and price setting equations from chapter 7. So here we have from chapter 7, which was on the WSPS model, from chapter 7. So we have the weight setting equation. So we have the weight setting equation given to us as W is equal to PEFUZ, right? Now, if we assume a specific functional form of f, so we're going to assume that specific functional form of f, if we assume that, so where we're going to assume that fuz, so this is just a general form, we're going to assume a specific functional form, which is 1 minus alpha u plus c. Now, a couple of things to note here. If we recall that here we know u, and basically the wage setting equation shows us the wage the workers demand, right? And there's a negative relationship between the wage workers demand and the unemployment rate because of the bargaining process, right? And z represents all those factors that allow workers to demand higher wages given the unemployment rate and expected price level, right? So we model z such that an increase in z increases the wages demanded by workers, right? So we can notice over here that that's why with u we have a negative sign and with z we have positive sign, because unemployment rate negatively affects the wages workers can demand. So, and hence the W and U will be negatively related in the wage setting equation. And Z, we model it in such a way that an increase in Z means there's an increase in the wages workers demand. Right? That's how we model it. And here alpha captures strength of impact of strength of impact of strength of impact of U on W, right? Right, so this is our weight setting equation, and then from chapter 7 we have our price setting equation, and our price setting, my bad, setting equation is given to us as we know P is equal to 1 plus M, where M is your markup W. So this we know from chapter 7. And this is stuff we have from chapter 7. Now let's actually do this, right? So how we're going to do this now, step 1 is going to be that we are going to substitute WS equation, right? This we know is a substitute WS equation into PS equation. That's the first step, right? We just wrote down what the WS equation is, what PS equation is, right? So what we're going to do is we're going to do, like, this is the PS equation, P is equal to 1 plus M. And we had a W here. So instead of that, I'm going to write the WS equation, which is PE. And then we were using a specific functional form for WS equation, right? Where this is supposed to be 1 minus alpha u plus c, right? So this is our WS equation, right? This is the WS equation, right? Because what we're doing is, we know the PS equation is P is equal to 1 plus MW, and the WS equation is PFUZ. But we're taking FUZ to be basically 1 minus alpha U plus C. So then this becomes the WS equation, right? Um, hmm. So this becomes the WS equation. So basically now we can just write this as P is equal to PE 1 plus M 1 minus alpha U plus Z. So now this is a relationship. So this is a relationship between P and PE and U, right? So now what we'll do is we will rewrite this equation. Now we want to rewrite this equation using time subscripts, right? So what we want to do is, we want to write, so we had this equation, P is equal to PE, 1 plus M, 1 minus alpha U plus C. Now, so we will rewrite this equation. So we will rewrite this equation using time subscripts, right? We want to add an element of time to it using time subscripts, right? So that we can refer to variables, so that we can refer to variables, so that we can refer to variables such as price level, right? Such as price level, expected price level, just price level, expected price level, or unemployment rate in a specific year. So we want to add the time element to it in a specific year, so that we know in which year are we talking about P, in which year are we talking about PE, in which year are we talking about you, right? So add time, include element of time. So time subscripts you want to add, so include element of time, right? Include element of time in it. So we're going to rewrite the same equation, but now add time subscripts to it. So we're going to write this as pt is equal to pet 1 plus m 1 minus alpha ut plus z. So now something to note here is that we want to note, can note time indexes. So we haven't added any time subscripts. Note time indexes on M or Z, right? I do not add a T here or here. Now, why is that? Why? We assume these to be constant, right? So we're taking them to be constant. We assume these to be constant because they're constant. So that's why you do not need a time subscript from them because they're not changing over time. Right, so now this was step one where we wanted to just substitute WS into PS and then add time subscripts to the equation that we get. Step two is, step two will be that now to go from prices to inflation, right? So far, the equation that we have is a relationship between P, PE, and U. But when we do the Phillips curve, but when we're looking at the Phillips curve, we're looking at the relationship between inflation and unemployment rate. So we want to go from prices to inflation, right? So we want to go to that. So to go from prices to inflation, what we will do is we will divide both sides by PT minus 1, right? Last year's prices, right? That's why, it was important to add the time subscript so that PT will represent this year prices and PT minus 1 will represent last year's prices, right? So we will divide both sides by PT minus 1, right? So this is the next step, PT by PT minus 1, 1 plus m. So we've just done that, we divided both sides by PT minus 1. Now this was step 2. Now step 3 is going to be step 3. Step 3 is going to be, okay, we will use definitions of pi t and pi et, right? So we'll use definitions of the inflation rate in EAT and expected inflation rate in EAT. Now, what are the definitions? Now, pi t, we know inflation rate in EAT is the percentage change in price from the previous period. So it's the price of this period minus the price of the previous period divided by pt minus 1. Now, if I just distribute this denominator, so this I can write as pt by pt minus 1, right? And then we can write this as pi t plus 1 is equal to pt by pt minus 1, right? And if you recall, when we divided both sides by pt minus 1, then on the left hand side, we had pt by pt minus 1. So we can substitute that with pi t plus 1 so that we can write it in terms of inflation. Similarly, expected inflation in year T is going to be the expected price in year T minus PT minus 1 divided by PT minus 1. So something to note here is that here we have PT minus 1, not PET minus 1, right? Because obviously if I want to find expected inflation in year T, I'll use expected price level in year T, but we'll still subtract it from last year's price level. We don't need to write PT minus 1 because at time T, when you're forming an expectation, for like inflation at time t, so you already know what the price level in t minus 1 is going to be, right? Last year's price level is known, so you don't need to form an expectation for it, right? So expected inflation is year t would be just expected price level in year t minus the price level of the previous period, which is known, so you don't need to put an expectation over here, right? So this is pi et is equal to pet by pt minus 1 minus 1. And then you can write this as pi et plus 1 is equal to pet. And this pt by pt minus 1 is what appeared on the right hand side of the equation in which we divided both sides by pt minus 1, right? So now we will just substitute pt by pt minus 1 with pi t plus 1 on the left hand side of that equation, and pt by pt minus 1 on the right hand side of the equation we had in step 2, we'll just substitute it with pi t plus 1. So when we do that, right, so right, if you recall, this was the equation we had, right? Pt by, from step 2 we had this, right? From step 2 this is what we had, right? Pt by pt minus 1 is equal to pet by pt minus 1 1 plus m 1 minus alpha ut plus c. So this we know is just equal to, like, 1 plus pi t, right? We just saw, and this we know is just equal to 1 plus pi et 1 plus m 1 minus alpha ut plus z. So now this is a relationship, but this is a relationship between. So now we have gone from a relationship between P, PE and U to a relationship between pi t, pi et, and ut, right? So that's the next step, right? So in step three, so in step two, we just divided both sides of pt minus 1. Then in step three, we use the definition of pi t and pi t to write this equation as a relationship between pi t, and ut. Now step four will be, okay, we will divide both sides of the equation we get in step three, divide both sides by uh, 1 plus pi et 1 plus m. So when we do that, we will get 1 plus pi t by 1 plus pi et 1 plus m. And the right hand side will just become 1 minus alpha ut plus c. This is step 4, right? So we divide both sides by this, right? Now step 5 will be, okay, as long as inflation, expected inflation and markup are low, as long as inflation, expected inflation and markup are low, the following approximation holds, right? So we're going to use an approximation now, right? The following approximations. We're going to use an approximation here. So the following approximation holds, right? Which is that we can approximate 1 plus pi t by 1 plus pi et, 1 plus m for the small values of pi t, 1 plus m. We can approximate it as 1 plus pi t minus pi et minus m, right? So we can approximate this with this, right? So we can approximate. So by this approximation, we can just write, so 1 plus pi t, so I just replace this with approximation. The left hand side is equal to 1 minus alpha ut plus c. Now from here, I'll just make pi t the subject. So pi t would just be this one gets cancelled out, and then we take this pi t over there. Then this just becomes plus m plus z minus alpha ut. And this is the general form of Phillips curve. General form of Phillips curve that we have derived from our WSPS model.